So in this study, we consider this as a preliminary study, so to speak, or maybe the first step. We don't claim that this is an exhaustive study that will cover all aspects of these very complex relationships. We simply hope that the results and the findings from this study will open a conversation and discussion and will catch the attention maybe of some university authorities so they can provide requests for additional studies that KIAS may really conduct in this regard. So with this important clarification, I believe that the results of this study will be taken within the framework and the restrictions within which we're hoping to provide the results. The purpose of the study. The purpose of the study is to examine important effects in the relationships among key variables at pre-college level and college level. So there are two major groups of variables. One group of variables is pre-college, before the students get accepted at universities, and the other group of variables is basically related to their university performance. Our study variables, in this study we focus on specific variables for which we have clean data, because sometimes we may desire many things, but data are not really available or not clean enough for us to conduct a proper study. So those study variables that we see is a high school major, art and science. It is important because all results here in this study are separately conducted for students with high school major in art and students with high school major in science, simply because they take different GAT and SAT. We have GAT and SAT art and GAT and SAT science. Therefore, we cannot mix those two constructs. They are different in scope and depth. It will be misleading if we just combine all those students together. Therefore, the results in this study are conducted, and derived separately for those two groups. High school students art is one group, and high school major in science is another group. Then we have a group of variables such as college major. Well, college major is used here as a covariate because we want to see whether students with high school art, for example, that continue in college art perform differently from students in high school art that continue with college science. So this combination is important. Therefore, we included college major, which is also art or science. Then, of course, gender. We all know that gender is extremely important variable for many reasons in the context of education in Saudi Arabia. Then we have pre-college academic ability and college GPA. And then at university level, we have three major variables that we focus in this study. College GPA for overall academic success at college level. Withdrawal from college. We need to know whether the students drop from college or not, and whether the students transfer their college major. So those are three key variables that we investigate at college level. So we have a group of pre-college and a group of college level variables, okay? Okay, now I will talk about this. GAT and SAT will be within the pre-college academic ability. We're going to use high school GAT and SAT measures as a latent factor of pre-college academic ability. That's the approach in this study, okay? And we perceive this as more efficient. Of course, there are other studies that may investigate predictability of GAT, predictability of SAT. This is not the goal here in this study, okay? So we have 5 research questions that we address in this study. The first research question relates, Dr. Faisal, to your question about the general academic pre-college ability, okay? We want to know whether high school GAT measures, such as verbal and quantitative, and SAT measures, they all measure an underlying pre-college academic ability. This measure is extremely stable, more dependable to provide feedback about universities, because universities take high school, they take GAT, and they take SAT. So all those measures, when they focus on unique latent factor, will provide more beneficial feedback to universities, we believe. Also, there is a previous article that was published by a team of NCA-related. This paper that was published in Educational Psychological Measurement actually investigates the development of general academic ability, application of optimal linear combination for high school students in Saudi Arabia. This paper was published by myself and another colleague of mine, and Dr. Abdullah Angatai. So in this paper that was published, and I received actually a very extensive and positive feedback about this paper across the world. Researchers across the world are very interested in measuring general academic ability, especially in testing companies and university researchers. I have not shared this with you, but I'm accumulating evidence about this, and this should be a point of pride for us, because basically that's a very positive feedback about what we're doing. Okay, I will just skip the technicality here, and I will show you from this article the major point. Okay. For students in science, those are the measures. We take the high school grades, we have got the total score, and from SAT we have domain scores. Why? Because for this study, that was the data available. And we measure GAA, which stands for General Academic Ability in Science. Okay? Then the same thing was done for General Academic Ability in Art, and this is the data that was available to us. In both cases, the study results support the existence of a general latent factor that we can use instead of separate measures. It is not a secret that in measurement that basically it is much better to use a general latent factor that captures the academic ability instead of individual observed variables, for many reasons that So let me go back to my research question. So the first research question is whether this data, which is different from the data that we have published and used before, will also support the same latent construct of general academic ability based on high school scores and NCA measures. Okay? In this way, this question is also important for us in terms of cross-validation of the previous study. And I will jump ahead. Fortunately, it was extremely well supported by this data as well, and we become more and more confident of using this measure of general academic ability. So this is the first question, to validate a measure that we then use in the subsequent 4 questions. So in the subsequent 4 questions, basically we're interested on the effect of gender, then the effect of gender, college major, and pre-college ability, how they impact the student's performance at college GPA, how they impact the rate of withdrawing from college, and how they impact the rate of transferring the college major. Those are the major research questions. The method. In this study, we use a sample of 124,715 students from 19 universities in the Kingdom of Saudi Arabia. Description of this sample is provided with the next slide, more detailed description of the sample. But this is the total sample of students that we use. In terms of statistical analysis, to address the first research questions, we employ a confirmatory factor analysis to test whether the measures of high school and GAT and SAT will support the existence of a single latent factor, which we call pre-college academic ability. Then, to address the following 4 research questions, we use path analysis in the framework of structural equation modeling, using the computer program M+. Okay? And also, I employ the 2-level SEM model simply because students are nested within colleges, so we want to account for the clustering of students within colleges. I have to make a comment here. Yeah, typically people, when they hear that there is information, say at university level or district level, oh, let us run HLM, hierarchical linear modeling. This is not always, all the time, a very good idea. So preliminary analysis should be done, carefully to see whether or not it makes sense. Especially this HLM or multi-level modeling is useful when we have covariates at the second level. For example, in my example here, the second level are universities. However, here we don't have covariates at university level. For example, that might be some index of resources of the university or some other indices at university level. With this data, we don't have such information. However, although such information is not available, and although our model does not really use predictors at the second level, it is also useful to use the two-level model for one purpose, to adjust the standard error of the estimates of the parameters. So the model parameters will be the same if I use one or two model, but the two model simply may provide some correction or adjustment of the standard errors for the model parameters. This is the only purpose of this use. So let us not get confused and say, well, you don't have covariates at second level, why using two-level model? It is still useful. It is still useful to use a multi-level only for the purpose of correcting the standard error of measurements. Although I should say that I played a lot with this data, and when I ignored the two-level nature of the data, the results, the findings were the same. Of course, the standard errors were different, but there was no differences in the main finding. The numbers were different, the p-values were different, but overall the findings were the same. So I wouldn't say that this is really a big deal here that I have used two-level model. With one level, the findings overall will be about the same. Okay, now here is the breakdown of the sample. On the column, you have high school major in art. This is one column, and then high school major in science. Then you have the grouping by gender, males and females, and grouping in college major, art and science. And this is the total. This is the total number of the sample. This is how many students I have high school in art, and how many students I have high school in what? In science. And I have to repeat again that the analysis was conducted separately for high school in art and separately in what? High school in science. However, college major was used as a covariate in the model. Okay. Descriptive statistics, I provide descriptive statistics here for the study variables, okay, which people who are interested with the technical report may go and have a closer look at those descriptive statistics. At this point, I don't want to comment on those. Now this is now our first research question. This is the statistical analysis, the model. It's a confirmatory factor analysis. And the data available for this particular study was high school GPA of the students, got quantitative score, and got verbal score and SAT total score. For SAT, I didn't have the domain scores here for the study. But that's okay because I have 4 variables. And I have to remind to my colleagues here that we need at least 4 variables to run a one-factor model, 4 indicators. If you have 3, it will be just identify model, always perfect fit, but it's not worthy. So I do have 4 variables, which means I can run the analysis to test whether those pre-college measures can really provide one major or more general academic ability, which we call pre-college academic ability. This abbreviation will be used across the presentation. So pre-CAA stands for pre-college academic ability, which is I would say, overall representation of the performance of the students across those. Well, the first thing we did was to test this model, whether the data will support this model. And this is what we did. And this is the first step. Those who are familiar with confirmatory factor analysis, we'll immediately see that these goodness of fit indices provide a support in favor of the existence of the latent variable. Actually, there's an almost excellent fit because these coefficients should be greater than 0.95 for excellent fit. They're point what? 0.98, 0.96. These coefficients should be smaller than 0.05, and they are. So basically, we do have a almost excellent support for the existence of one general academic ability for students in high school in art and high school in what? In science. I will remind you that this here will be different from students high school in art and science because those measures here are different for them in terms of depth and scope, as we perfectly know that. Okay. Now, there's an additional information. Those are the factor loadings which tell me, for example, how well each of those measures relate to this general ability. Typically, if those coefficients are greater than 0.4, we call them, there is a substantial relationships or correlation between those indicators and the latent factor. In this case, they're all higher than 0.4, and even up to 0.92, right? And high school behaves very well, although not as well as the NCI measures, because I should make some deviation here and say that we have a study about leniency or misbehavior from high school grading, which actually is reflected also here. I believe that's why this coefficient is relatively lower than the others, but still high enough, higher than 0.4, to claim that high school is also an important measure for this particular study. We cannot just ignore it. And this is the same for art and the same for science, almost the same trend for art and science. So with those two results, we can say, okay, our pre-college, high school, and NCA measures allow us to play with what? A general academic ability, pre-college ability. Halas, this is our first question, first research question. Now we move to the actual research questions. Yes? Is
this for female and male?
No, this is for both, for everybody, yeah. The effect of gender, now this is the real model, basically, for the research questions 2, 3, 4, and 5. Actually, the relationships that we're interested in. The first research question is simply to validate the meaning of this measure, by the way. As you can see, this is a path model. All those variables here are observed variables. If I have only observed variables, this will be path analysis. But because I have a latent factor, with the path model now becomes structural equation model. Okay? And this latent variable is examined at the previous step with relationships to research question 1. So this is our path model. What do we see here? Here with this model, if you see this arrow 1, no, it's within the framework of the model. I don't calculate factor score separately and then include them in the model. No, that's a disadvantage. You do this only if you don't have any other resources, or I have to use this in another model. Yeah, if I do this, then it will be a pure path model in this case. So basically, all parameters are estimated within this framework simultaneously, so to speak, which is, as we know, a good benefit for the study. Now, let us focus, what do we have? What do we examine here? You can see this arrow, gender to pre-college academic ability. This arrow is a direct effect. Muhim jiddan, very important. I have to specify and clarify that we examine not just correlation coefficients, which is typically done, but we do the following thing. I will clarify two major concepts that I use in this report. They're very important. Let's say you have one variable. I call this variable X. Might be gender, might be college ability, whatever it is. Let's say we have another variable Y, and let's say I have a variable Z. 3 variables. Typically, If I want to use if I want to examine the correlation between x and y, there's not much information. Here the question is to break down this correlation into components. For example, I can see that I may have direct effect from x to y, and it's called path coefficient, which is regression coefficient, practically. Let me call this just P1, one regression coefficient. Then I may have effect of x on z. Z is a mediation variable, mediator, and then effect from z to what? To y. If I call this P2, and if I call this P3, now this regression coefficient, the regression coefficient between x and y basically will be the direct effect plus indirect effect, because x may affect what? Y through the mediation of z. And this mediation effect basically is the product of those two coefficients, P2 times P3. We call this direct effect, and we call this indirect effect, and the sum of direct plus indirect gives me the total effect. So there are three effects that you will see in this report: direct effect, indirect effect, and the sum of those gives you what? Total effect. Of course, there are other effects which are not involved in this model. If, for example, z is a common cause to those, you will have some spurious effect and noise that you cannot evaluate. But in our model, we don't have such effects. Typically, each correlation coefficient you can break into 4 possible effects. But the desirable situation is that you have direct and what? Indirect effect, because the other pieces are unknown, noise, or effects that you cannot estimate. But with our model, we don't have such effects here, right? So for me, it is important for us to clarify that instead of correlation coefficients, we break down the correlation coefficients into direct effect and what? Indirect effect. And this is very, very important indeed to understand. Now, with this clarification, I can say that if you examine gender to pre-college ability, there is only direct effect. There is nothing else. However, if I want to examine the gender on college GPA, you can see that this arrow number 3 is the direct effect. But I also have indirect effect, for example, 1 and 5. If I multiply the coefficient of 1 and coefficient of 5, that will give me the indirect effect of gender to what? To college. And this pre-academic ability plays a mediation role. This is mediation role. So this is actually the approach of this model, and this is the way the results are interpreted. Through the analysis and estimation of direct effect, indirect effect, and total effect, which is the sum of both. Sometimes it might happen that direct effect has positive sign, the indirect negative, and they to some degree cancel out. So you may see the total effect smaller than the direct effect, for example. So don't get surprised of this situation as well. Okay, so those arrows here, they reflect the research questions that we defined previously. Now, I will provide some information about the coding of the variables, because coding is very important for us to know how to interpret the coefficients. For example, in this model, if the regression coefficients from gender to pre-college ability, let's say, is positive, how should I know how to interpret this? I need to know the coding for what? For gender. Well, if gender is 0 for male and 1 for female, I will say, positive coefficient tells me that females perform what? Higher than males. So in this sense, it is important indeed to clarify the coding for males and females. Now, I kept the coding, it was in the original data, okay? And if you look at the unstandardized coefficients, that might be a little bit misleading. However, in this report, I provide only standardized coefficients, so they are comparable to each other. We don't have a problem with this. And here, this note actually relates to what I just explained about the interpretation of the regression coefficients given the coding of those variables. given the coding of the variables. Now let's move to the results. We run the results with the data for high school major in what? In art. And those are the results. In these results, each arrow has two numbers. The black number, black color is the direct effect, and this is what? The total effect. I have in the technical report extended detailed tables where I provide all indirect effects and so forth. But in this case, let's focus only on the direct and what? And the total effect, okay? So just for the sake of illustration, what does this tell me here? 0.25, it's a standardized coefficient. They look relatively small, but remember those are standardized coefficients, which if you square them approximately, let's say 25% is explained, right? 0.25, which is not bad at all. Now, 0.25 tells me, because it's a positive, and because gender is 0 coding for male and 1 for females, that tells me that females perform better on pre-college ability. In other words, the integrated performance on high school and NCAA tests, females perform better than males with high school major in what? In art. This is how I interpret this direct effect, okay? And I don't have a black number here. Why? Because this is the total effect, because I have only direct effect. If you have only direct effect, the total effect equals the direct effect. That's why if you see only one number, it means there is no indirect effect. Here, for example, I have two numbers, direct effect and what? And total effect. Okay, direct effect is gender on what? On college GPA. It's a positive number, which tells me that females, again, have higher performance on college GPA. Both direct effect and total. But the direct and the total are almost the same, which means that this indirect effect is negligible. So the indirect effect is more negligible here. Okay. Of course, if we get to the tables, you will see all details of all possible indirect effects. I should say that sometimes you may start with one variable and end up with another variable through many different indirect effects. If you sum all indirect effects, that gives you total indirect effect. So then the total effect will be direct effect plus total indirect effect, right? But in this case, as I said, I don't want to overcomplicate, but the tables are there available for analysis. So what we see here is this picture, and I have summary table that we'll see in a while. Let's look at the high school major science. Again, just for illustration, gender for pre-college ability. Well, unlike the previous case, where it was 0.25, kind of substantial standardized coefficient, now it's negligible. And another clarification is important, because the sample is so large, even very small coefficients are statistically significant. We need to keep in mind that we need to focus on the practical, importance of those. And I would say that in this case, this effect is kind of negligible compared to what? Compared to high school art major. In other words, I would say there is no gender differences on pre-college ability for students with high school major in science. But for high school major in art, females perform better. That's one of the conclusions. Now, this table summarizes those previous graphs in a parallel fashion. We have for high school art direct effect and total effect, and for high school science also direct and what? And total. If you compare the total effects, you can directly see, say, the effect of gender on pre-college ability, the total effect for art, and the total effect for what? For science. You can immediately see that obviously females in high school art perform better than males, but this is not the case for what? For high school science major. Then we can directly compare 1.1, 0.2, and negative coefficients here. This is the effect of gender of what? Withdrawal. Whether gender plays any role of the students will drop from college or not. Now, I have for students in art, there's a negative effect, almost the same magnitude for both art and science. So it doesn't matter high school art or high school science, the effect is the same, however, it's negative. What does this mean? It means that because males are 0, females are 1, there's a higher rate for males, higher chances for males to withdraw from college. That is the interpretation of this, because withdrawal is 0, no withdrawal, 1 is what? Withdrawal, yes. 0 is no, 1 is yes. And if you keep in mind this coding, you will know how to interpret this coefficient. It tells me that males have higher chances, higher risk to withdraw from college compared to females, regardless of high school major, art or science. Yes, Dr. Abdullah. There is indirect effect that the difference is in indirect effect. Very good point. If you subtract from this number, if you subtract this, you will get the indirect effect. But in the technical report, I have detailed tables with all indirect effects and the total indirect effect as well. So you can get this information. But that's a good point. Basically, the difference between the total and indirect effect is exactly the indirect effect. In terms of total indirect effect, the sum of all possible indirect. Dr. Faisal.
Yeah. Do you think that the sample size has an effect on the results here?
No, the sample size, as I mentioned, if I understand your question properly, the sample size will signal statistical significance for relatively what? Small effects. Just like this one here, 0.065, let's say statistically significant. But we can judge whether or not this is practically important. For example, if I compare 0.25 to 0.065, even though they both might be statistically significant, I will say, well, I will treat this as a negligible. In other words, gender differences are negligible for science high school compared to what? To gender differences for art. That's.
How did you take the sample? The sample is one cohort, complete cohort?
No, those are from 19 universities. Okay, those are from 19 universities.
One year?
Yes, it's about within the same time. They're not spread around the years. You know, yeah, one cohort of.
One cohort.
Yeah.
And as you know,
That's my understanding.
As you know that art for females are more than
Yeah.
art.
Yeah. Well, no. This is the breakdown, you know, by gender, for example. See, males are 7,000, 8,000, females are what? 32,000. However, this balance in sample is not a big deal given the very large samples, actually. I wouldn't say this is not like a 15 compared to 50, but 8,000 and 30,000, I wouldn't say that this will affect really the accuracy of the estimation at all. So the samples are large enough. The samples are large enough, as you can see everywhere, the samples are large enough to kind of secure, you know, credibility of those estimations. That's my.
Of course, there is another factors that affecting also selecting art or science, you know, between boys and girls. You know.
Yeah, well, we have the effect of gender.
For males, especially males, those who are not good in math and science, they go to art.
We have this too. Well, don't worry, we'll get there.
That's why they are not really a good representing. So not the gender by itself.
Yes, but.
Choices that's given.
And it's evident here, you know.
Yeah, there's evidence here on this issue as well. So, college major. Okay, ta-da! Here we go. College major. Let me follow through. Transfer. When it comes to transfer, at art, students, high school art, more females tending to transfer compared to what? In science, where more males tended to transfer. It's just the opposite sign. It's a very interesting, actually, refinement of the finding. Here, this is positive, and here, this is negative. They're about the same magnitude. However, this tells me that at high school major art, females are more likely to transfer their college major.
At what time of the college? You studied all the period?
I don't know, all the period, yeah.
Till they graduate?
Yeah, within the graduation, within the period of graduation, whether they transfer their college. Well, that's what it says, because we have first semester, second semester, and college GPA. It says college GPA, which I assume is the graduation GPA. Are you sure? I'm not. That's the data I was given.
I can't explain. Always
I think people here can explain better this than I.
when we ask for data, we ask for
The collection of the data last year.
4 semesters or something like that, right?
yeah, for
Yeah.
No, I think 4 semesters.
Okay.
that's what we ask.
4 semesters.
Yeah. Over 4 semesters?
Yes.
Yeah. This information is not provided with it. It says college GPA. Halas.
Yeah, I think where we
Dimitrov is not psychic, I don't know.
It should be clear. It should be clear in the data at the beginning.
Yes,
Should mention
it should be, but
explain that.
Yeah, those 1,204, all of them are studying the second year or third year, or they graduated.
No. The fourth semester.
They are on the fourth semester. All of them fourth semester.
that's, yeah, this is something I remember this. 4 semesters of study, yeah.
So studying withdrawal for
Yeah.
fourth semester.
Yes.
All are consistent.
Yes.
Not some of them 1 year, some of them.
No.
All in the
Withdrawal, will change the major in the 4 semesters, not the whole 4 years.
No, it could be any time and up to the fourth semester.
Okay, so I hope this clarifies the issue.
We'll give you the details.
Yeah, okay. I can get some details from reports of the Ministry of Education or whoever has this data. I was not provided this information additional. Anyway, but I remember that there were 4 semesters mentioned in the paper. The first 4 semesters. Okay. So I was here with the gender transfer. Now I move to the role of college major to college GPA, which is negative for art, which tells me that what? What does it mean? College major. College major, 1 is art, 2 is what? Science. Because it's a negative sign, students in art, which means in college, those who have high school in art and college major in art perform better.
Again.
Okay. Students high school in art, right? Some of them, high school art, high school art. Some of them go to college what? Art. Some of them go to college science, right?
No, it's the other way. The high school science.
Art cannot go.
High school, you mean high school art, none of them goes to college science? Okay, high school science, can they, some of them go to college art and some of them to college science? Is that possible?
Yes,
it is.
Okay, well,
the first one is possible depending on the classification. What's
yes.
science, what is
So,
art, but
is this possible? Is it possible that you have high school art and some of them pursue a college art major and some of them college science major?
depends if you classify like
No, this is the way they are classified in the data. You know, I explicitly have a data where, and I can tell you how many are there.
Yeah, it depends on the.
I don't know what depends on this, but this is what I have. High school art, college major art, and college major science. This is what we're talking about. Here is high school art, and 37,000 people pursue college art, and 2,500 pursue college science. When it comes to high school science, this is how many of them pursue art, and this is how many of them pursue science. Okay, whether or not we're going to pay attention to this, that's a different thing. What I'm just saying that given this data, say 30,000 versus, for these people, art, those who have high school art and pursue college art, perform better than this. However, here, there's no difference. For students high school science, it doesn't matter they pursue art or science, there's no difference in the GPA. That's the interpretation of results related to this breakdown, okay? Then, in the same way, college major with withdrawal. Here is positive, okay? What does this tell me? Because, again, college major, high number 1 is for science, means students in science are more likely what? To withdraw if they have high school art. Here, however, this effect is not really substantial at all. So, in other words, this number here, this small number, not just small, it's not even statistically significant, practically 0, which tells me that students with high school science, right, their college major does not play any role on whether they will drop from college. So students from science, whether they go to art and whether they go to science in college, doesn't matter. It doesn't affect their decision to withdraw from college. That's basically the message from this. And then college major to transfer, the same thing. The same thing. Students with high school art, right? Those who pursue college in science are more likely to transfer. In other words, I have high school art. I went to college what? Science, but then I'm more likely to what? To switch, to transfer. Maybe they realize that, well, it's not a good choice or whatever. I don't know the reason. I don't want to speculate. However, students from high school science, when they go in college, they're not, likely to transfer based on their college major at all. That's the issue. And then we have issues on effect of college GPA, whether college GPA will affect withdrawal, right? It's a very substantial coefficient here, negative. Negative coefficient means what? People with higher GPA are less likely to withdraw from college. And this is for both, regardless of what? Whether art and science in the high school. So the message here is regardless of high school major, high school GPA, college GPA, the higher the GPA, the less likely the students will drop from college. The same, however, college GPA does not affect the decision to transfer. College GPA is not a factor in the decision to transfer the major, the college major. See, college GPA to transfer, not substantial or negligible in both cases. So those two numbers here, they tell me that, yes, college GPA has a huge role in dropping from college, right? Positive role, but not for the decision to transfer their major for whatever reason. Then we have, now this is an important for us. For Kias, this is important relationship. Pre-college academic ability, how does this affect what? College GPA. It's a positive for both art and science, and especially for science. In other words, The higher the KIAS scores, the higher the college GPA of those students, especially for those who pursue science, right?
Not only this is high school ability. How do you calculate this summative effect?
Well, that's within the confirmatory analysis. It is a composite score based on high school and SAT and GAT domains.
Same weight?
Say it again?
Same weight?
No, not same weight. The weights, if you want to see the weights, here are the weights. Those are the weights. Not the same weight. Of course, if it's the same weight, it's not a model anymore. It's just, random.
Wait, why is it quantitative has a high weight for the art?
Yeah, because
And the verbal has high weight in the science?
no, this is how well high school, relates to this general academic ability compared to the GAT measures. Okay, and there are many reasons for this actually. One of which I assume is, as I mentioned before, the misbehavior of high school grades compared to KIAS grades. You can just refer to the study related to leniency or inflation of high school grades. You may see that this effect may play some role here. The bottom line is that the score of the students here, is a composite score of this based on how well they relate to this general academic ability. And this is a true score. There's no error. If I have to really teach about this, this is a true score. There's no error involved here in the student's measure. The student's performance, errors are involved here, 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 and here. These arrows here indicate that those are observed variables, and they're always associated with errors of measurement. But the score of the students here is a true score on the pre-college ability, which does not involve error. So it's much more stable, and there's no error involved. And most importantly, you can measure this by different subset of the way I illustrated with the paper that we published. A paper that we published, instead of SAT total, we had all domains in SAT, right? But you still measure what? Pre-college academic ability. And I believe that this is an extremely important measure to keep in mind, because the university decisions actually should be based on this, not separately on combining with the same weight observed scores that contain measure and that are not equally representative of the pre-college ability that universities should be interested in the first place. That's the whole thing. Anyway, so
Can we, by the way, from the factors here,
factor loadings?
This one.
This one?
Can we extract any recommendation for weights given to the admission variables?
Oh, this is done in the paper that we have published. There is a model for maximizing reliability and optimizing combination. This is not the goal of this study at all. But you're right. This is an important procedure which is fully described in our paper, which I just mentioned.
This is a good idea to recommend it to the
Yeah.
university.
Yes, I agree. But that's why we have those studies. From these studies and our discussions here, we can come up with some more meaningful recommendations to the Ministry of Education. That's the whole idea. I'm glad you kind of come to this point. Let me just finish this, and then we can go to... So I was here, how pre-college ability influences. How about pre-college ability and withdrawal? Okay, the same thing. The higher the pre-college ability, the lower the chances the students will drop from college. To me, those two measures, this, and the same here, even stronger for what? For high school science, is a validation of the predictive validity of GAT and SAT, if you wish. That's an important thing, because they both indicate that the higher the pre-academic ability, which is heavily represented by GAT and SAT, actually, you have higher GPA, and you have lower chances to withdraw from college. That's it. This is a very important point, or one of the aspects toward the predictive validity of gut and SAT, I would say. Extremely useful evidence, extremely useful evidence. And let's not forget that we need to collect evidence. There's no single shot analysis that gives you information about predictive validity. We need to collect evidence. Yeah. Yes, I can say that these two results here, the first one tells me that the higher the pre-college academic ability, the higher the GPA at college level. And also, the higher the pre-college academic ability, the lower the chances that they will drop from college. Right? So together, they're positive indications of the predictive validity of gut and SAT. That really are the main ingredients of pre-college academic ability.
Can you go back to the slides of the weight, please, for one last time?
Say it again?
The weights of the model.
Yeah, sure.
Yeah, because I remember our College Gpa has been conducted a study from 2002 until 2007 for all students who entered the university during that time. And what they found is that course achievement is number one, is the most predictable variable for GPA as a whole, cumulative GPA. Second was high school, that's like what we have here. So maybe there is some changes is going on there.
Well, those numbers would...
Or maybe because we are breaking down the gap to two sections.
Okay, now, let me look again. Let me go back to this paper. Okay, let me go back to the paper. This is from the previous study that we published, and you have different measures. You have high school here, right? And those are major in science, major in science. High school grade, this is the loading, right? And then you have gut total, and you have 4 what? SAT domains. As you can see, again, high school is lower than any of those indicators of NCA measures, gut and SAT. Although it's a different set of, observed variables, right? So this is consistent, actually, trend.
Also, this is on the summative data on all universities together.
Which one? This is from the data reported in this paper, not in this study.
I mean, you run it one time, or one time. You do it for every university and this.
No. So it's a summative data. Yeah.
But also the meaning of achievement is as achieved.
The bottom line is that, the trend is the same.
It was administered before by the ministry, now by high schools. It's all different.
The bottom line is you have high school and you have gut and SAT measures, right? Whatever you do, the most important thing that they all together fit very well to represent a one general academic ability. This is important. In other words, it makes sense and supports the argument that we can provide to universities that they can use a composite measure based on this model for more accurate, so to speak, evaluation or diagnostic of pre-college academic ability. They care about this. I want to accept you in college. What is your pre-college academic ability, right? They don't care about exactly high school or SAT biology or whatever. Of course, they may refine this with other things, but still. Then, within this model, obviously, high school comes with a lower loading. Yeah. Yes?
You can also do, first of all, like when you said this was very important from the NCA's point of view. A small remark is you can only
Well, you can do many things, but the bottom line is that you have to be smart to do the most important things. If you include 100 variables, you'll get, fuzziness that you cannot get out of the.
For the sake of accuracy, and the second related point, more important is there is also phenomena of range restriction, because if you look at the range of the students who are getting high school GPAs and those who are going to university is much more restricted, and that is also attenuating the correlations. How can that be taken into account here? Because
You have to conduct a separate study on predictive validity where you have to take the restricted range, right?
exactly.
That's it. Something that we have done
Yes,
as well.
something you would have to use multiple correlations and then
Yeah.
look at it. But is it possible to incorporate it somehow into your method, or
Doesn't make any sense to use it here because it's a different study.
Sure, if it is
Yeah.
these correlations will go
Yeah.
high.
It's a.
One thing is sure.
I cannot incorporate simply because I involve college measures, and for the other people, I don't have college measures, period. For the other people, it's a separate study for predictive validity where you can correct the restricted range based
you
on,
also have to use multiple
yeah.
correlations? It's not possible to do it.
exactly. Yeah. Okay. By the way, I will cheat and I will go directly to main findings. The main findings basically is, the first is validation of the pre-college ability, which we already know that it's well documented from both previous studies and the current study. And then regarding gender effects, I can say for high school major, I broke down this to high school major in art and high school major in science. When it comes to gender effect, we can say for students in art, females outperform males on college ability, but this is not the case for science. Okay. Here, regardless of high school major, females have higher GPA than males, with the difference is somewhat more pronounced for college science. Again, regardless of high school major, males tend to withdraw from college at higher rate. And for high school major in art, males tend to transfer college major at higher rate than females. For high school major in science, females tend to transfer college major at higher rate than males. That's an interesting switch here. Then we have effects of college major, but I already provided some comments on those effects, so unless you want to really focus on some of those, let me know. And then we have effects of pre-college academic ability. As I said, for me, the key message here is that pre-college academic ability provides support for the positive role of those NCA measures, because the higher the pre-college academic ability, the higher the GPA, and the lower the chances to drop from college, period. Those are the two key messages, regardless of high school major, art or science. I believe this, for us, this is an extremely important message, okay? And effects of college GPA. Of course, regardless of high school major, students with higher GPA are less likely to withdraw from college. Regardless of high school major, college GPA does not play a role in the transfer of major. In other words, college GPA, the higher the college GPA, the less likely is that the students will what? Drop from college. However, college GPA does not affect their decision to transfer. They may have high or low GPA and still decide to transfer. Of course, that might be for different reasons, but we don't know this now. Well, thank you very much for your attention. I'll be happy to continue with questions and discussions, so go ahead. Those are very close, yeah. Those are very close to partial correlations, but if you square them, they still give you the unique contribution of this variable above the effect of all other variables. So you may still square those and get some information about what % of the variance in this endogenous variable is explained by the respective predictor. However, because those are standardized coefficients, typically people think of up to 1. They're all smaller than 1. So the closer to 1, the higher the ability. Practically, how much is practically important? It's a subjective decision. It's not something that you can say, well, this is, say, 20% is practically important. Sometimes even 1% is practically important if you save the life, say, out of 100,000 people, 1% saving life, is huge number. So the practical importance in educational settings, we believe that 40% explanation is very substantial, very substantial. But the way I see it, I will say here, yeah, 0.25 is quite substantial compared to 0.06, which to me is negligible. Although they're both statistically significant simply because of the very large sample in our study, which is a good thing. I mean, but even though there are some not significant at all, regardless of the, like this one here, 0.005, despite of the large sample, is not statistically significant. That's why it's not in bold. In bold are given only the statistically significant. So if you see this not in bold, it tells you that it's not. But I would say that more extensive, careful reading of the technical report will provide, some additional clarifications on those issues. But again, going back to your question, there's no golden rule of thumb to tell you how much. We need to very intelligently decide on the scale of 0 to 1.25, do we have to consider this as important or providing the message or just ignore it? I would say that at this point we can just play with some effects that are statistically significant but ignorable, especially below 0.1. Below 0.1, less than 10%, I would say is practically ignorable. But all those here are higher than 0.1, as you can see, except for this one. See, this one here, I can ignore it. It's 0.01. All those statistically significant, helly welly.
Second question, our note here is that, in my opinion, the major transfer is not always a bad thing. Okay, you should not consider it as a bad indication.
We're not considering it a bad thing here.
Yeah. Because though it has no relation with the college major, with college GPA.
It doesn't, yeah.
That means there is satisfaction. That's
very good point.
He's there, he's doing fine in his major, so he doesn't need to transfer. But the last row here shows that the pre-college ability has a relation with major transfer in science. That means those students has the potential for them to be accepted as a transfer.
Yeah.
In major.
Yeah,
because they have to prove some abilities to be transferred to another favorable major in college.
Yeah.
Because sometimes when they admit them in a major that he doesn't want. So when he tries within his study, he can get the transfer. That means this is a very good indicator that pre-college ability is a good indicator of whether he is going to be accepted for another.
I agree, Dr. Faisal.
Upgrading his major, actually.
Yeah, it's a good point. But I should remind all of us that here we're providing what is happening. Then why is this happening is a totally different ball game, and you're putting your finger on the right button. I would say this is now the people here that should put their heads together and say, this is what is happening. Now, why is this happening is the next round of research and discussion. That's a very good, and I totally agree with you. That's why I mentioned that a positive effect of NCA measures are related to GPA what? GPA at college and dropping from college. I didn't put transfer here in this range because I don't know to what degree this is positive or negative. It's a very complicated issue, and you mentioned some possible explanations, but this is something that should be done at substantive level by people who really are in the context of this issue and provide more exhaustive, I would say, set of explanations why is this happening in terms of transfer to knowledge. Maybe we need to combine this with additional information. There are surveys that should be done with students. Okay, why did you transfer? And relate those variables to outcomes of surveys. This is I mentioned at the beginning, the first step. I don't consider this a complete, exhaustive study on all possible aspects of the relationships between pre-college and college variables. There are other things that might be included in the second stage, and I hope that this, first study will provide a good, feedback and motivation for continuing this study indeed. And especially the first round, we can try to explain why is this happening. We may go back to universities and conduct survey with some students or with university administration people or professors. That's a continuation of this study. That's the way I see it. The limitations are obvious. It's something tells you that. But I wanted to really put the point on some numbers that I would believe those trends will remain stable no matter what. But it doesn't mean that they tell everything. There should be some refinement with some additional, variables that should be involved for a second stage of this study when we get the data, inshallah.
I would like if you add also another, study or correlation between the, for science major, for art major actually, for art major, whether he is from high school, science high school or art high school. The difference between them. And in a previous study, we found that those who comes from science high school major, they are doing much better than the art students.
Okay, now
in art colleges.
Now let me.
Although even with higher GPA, high school GPA.
No, depending on what university. Depending on what.
In general, we took it last time and
KSU, yes, this may
Not in your university.
even in Imam University has shows that science students are doing much better in art majors.
Okay, now let me. If I understand your question properly, again, you're talking about students with high school major in art, right?
In science.
No.
In science. Is that what you're talking about?
Which goes to
No, majoring at university in art.
Here, college major in art here.
Yeah.
This row, okay? Well, those are the numbers of those who come from high school art, and those are the numbers of the same students who come from high school science. So what is your
If you
question?
compare their performance at college.
Oh, this and this?
Yeah.
Yes, I do have this.
But
In the result, yeah, they are compared.
No, comparative between the two groups.
Yes, but this is the role of college major for students in art. Okay?
No, you took them separately. You didn't mix them.
they're comparatively stable, in fact. 0, 1, 4, 8.
I cannot compare students with high school in art and high school in science on pre-college ability because the GAT test for art and the GAT test for science and SAT for art are different. So direct comparison here will be misleading rather than supporting. If you want to compare horizontally high school art and high school science, I don't do this.
Even if we consider them the same, they will.
Well, no, I don't want to go there. I cannot consider them the
No,
same.
art should be easier.
Well,
the same student go take the GAT for art, he will get more higher score in that.
well, that should be different data, so to speak, so we can really.
Although this is a fact, but their performance at colleges.
Yeah. Well,
I think it's fundamental not get to a point. I mean, talking about students who graduate from high school for science, and they choose in the college to go to art.
Yeah.
yes.
You see,
Compared to those who come from art high school.
they come from science high school.
Yeah, but they have different tests at high school.
this is the role of college major. You have role of college major on GPA, college major on withdrawal, and college major of transfer. Now, the role of college major for students with high school science, right, is negligible. In other words, college major means college art and college science. There's no difference in the GPA of those two for students who come from high school science, right? And there is a difference between those two, although not very large, but still in favor of college art, because college art is, the code in college art is 1, college science is what? 2. And because it's a negative sign here, negative sign, it tells me that the higher the college.
I'm talking about high school.
Yeah, but as I said, I will not compare high school major art with high school major science. In this study, I don't conduct such comparison.
But I am adding.
Oh, this should be a separate analysis. Then okay, well, we can do this. Yeah, we don't have problem with this. We can run it here. But as I said, mostly because here, this latent factor, this pre-college academic ability is not the same thing for students with high school art and high school science. That's the reason here they are analyzed separately. But as you said, additional analysis could be run where I'm not going to use this variable at all. Then I will compare those only here. Well, this is what you're asking practically for, so there's no problem. It's a trivial comparison. We can do this, even include it in the report. Yeah.
Can I say
sure.
something? I saw. Can you show the table with the coefficients?
Which coefficient? This one?
There is one, let's say, two numbers which are very interesting according to my opinion, where regarded to pre-college academic abilities to withdraw from the study.
Here?
There are no direct effects.
Yeah, there are no direct effect.
Yes, this is important thing,
Yes.
I think,
Yeah.
because in fact, all the effects are due to the indirect effect which are in
GPA, actually, primarily
Yes.
GPA.
So this is one of the
College
important
GPA.
things.
Yes, I agree with this. And those things in the report are clearly stated that if you look here, there's no direct, the pre-college academic ability has no direct effect on withdrawal, right? You cannot say, because you have low pre-college ability, we can guess whether or not you will have higher chances to withdraw. No, there's no direct effect. There's only substantial indirect effect through college GPA.
College GPA.
Yeah, college GPA. Because here it is. There's no brainer. Here is the here is the pre-college ability, and here is withdrawal. And this is the indirect effect from here, right?
Again, college GPA is also affected by another factor that's non-cognitive.
Yeah. Then, as I said, we may refine to include other variables, but here, see, the direct effect is dotted line, which means it's not significant at all. We can ignore it. Actually, the effect is through this, consecutive paths. You go 0.12, and then you multiply this, and you get the negative number that we get. Yeah.
Just a suggestion, don't you think that there should be indirect effect for pre-college or pre-college ability to college GPA, which including the college major, because the cumulative GPA will affect what college the students will go to. And that should be, I think, should be taken into account when we try to see the relationship between pre-ability or pre-college ability and.
I'm not sure I understand your question.
We see the college major here.
College major here, yeah.
Should be an arrow coming from the pre-college. Yes, here, down there.
Here?
Yes.
No.
No?
Meaningless, totally meaningless. How can I say that pre-college will have college major?
Because
No.
It depends on the score, that's also.
Well, it might be, but I don't think this is relevant to my research questions here, because pre-college ability, if I run this, I have to run logistic regression to see what are the chances, right, that people with higher scores will have higher probability to what? To select college major? It's very fuzzy to me at this point. I don't consider direct effect from here to here
This is very broad.
relevant.
For science, there is no medicine, engineering, or
Not already there, but still, I want to know because the students, you order them based on their scores, right?
But I think it's evident.
No.
It's self-evident. Because of the structure or the process of selecting.
Yeah. I don't know. I don't believe that the higher score directly will provide me valid information about the choice of major, whether this is a student choice or the university put them. There are lots of intermediate players that may really confound the outcome, and I prefer not to include it at all.
Very subjective.
Yeah.
What is fashionable now?
Yeah.
I don't want to add any complexity to this because it's already
Yeah.
there. But it would be more interesting, at least for me. I mean, if I look at the pre-college ability, having the background from your previous studies on the high school grade inflation, spatial
You want to include.
significant differences in student performance and GAT and SAT.
If you involve high school grade inflation, it's a different study.
Pre-college ability, if it is at least referred to or have the factor of the space or spatial distribution listed in there, we'll see how it differs from region to region or something.
Yeah, we don't have this. I don't have this data to start with. No, I mean.
Leniency study.
Say it again.
The leniency study.
Yes.
Yeah.
That's a different study, actually.
Yeah, it is different, but it relates to what the
Yeah.
is saying.
Also becomes, I think, 3-level in M plus you can't do 3-level analysis, right? At the moment.
Say it again. 2-level, yeah.
No, if you start including
If I have to include regions,
it becomes 3-level, right? And in M plus, I don't think you can do
it does. Yeah, you can do it. Yeah. You can do 3-level, but don't forget that a meaningful analysis should be done at least 30 clusters. We have only 19 and 10 here, and it's all across the places that to consider this is a random factor. They should Motain and other discussions in M+, they suggest from 30 to 50 clusters. But if you want to include the aspect of grade inflation, if this is your major point, right, that should be.
Actually, my major point is the spatial distribution of this pre-college ability. How would it differ from place to place within the kingdom?
Oh, that's a different study. Yeah, the distribution has no actually. Let me remind you, in the study for grade inflation, actually, we define grade inflation exactly on this common ability again, that people with the same, schools with the same common ability, right? If they have different performances on GAT and SAT in high school, this will be indication of the inflation, and that your question is more answered within the new study that we have, a revised study on grade inflation, by the way. I believe this will be something that you will need, and I think I can pull it in here. I can show you, just if you give me 1 minute, I will be able to pull this out for you. Yes. Oh, go ahead.
Yes.
Sorry,
We talked about grade inflation in high school.
Uh-huh.
We know that the grades are inflated and low.
Not all, not all.
High school.
Yes.
In general, you have 86, the average. Standard deviation is very small. The only standard we have reference is
Here's the
CA tests, right? And
No.
CA grades. My question, or did you examine the variation in the GPA in the universities, that you have 19 universities now, the average of the GPA in each college across these? Did you examine, is there
No.
big variation among?
No, because this is not, part of those research questions. I mean, you're asking here questions for so many trivial statistical comparisons that we can do in a separate study. I mean, why do I need this?
Because it's not standard. The only reference for the grade I have, NCA grades are coming from standard tests.
Yes.
Common tests.
Yes.
Okay. But GPA in the universities, for instance, Science College in KSU is different from UBM. The average, if you see the average of the students, if you go to the other universities, Science College.
But that's why we run. Okay, that's why we run two-level analysis to account for cluster differences.
No, I don't very too many details. But did you look at this, the average of GPAs, the variation of the GPAs depends on the universities.
Why should I look at this? I don't need this.
Yeah, just if I would explain.
The differences between colleges here are reflected within the model that if you use two-level model to adjust those differences that you're referring to. I don't need to know exactly how each school compared to each school. I assume that there are differences and they are reflected into adjusting the standard error of the parameters that I'm interested in. I have here a study with research questions that relate to relationships, right? And the performance of colleges and differences across colleges are reflected and taken into account with this two-level analysis. Halas, if I want to compare colleges, that's a different study, which I am not doing here.
You mean the model will take?
Yes, take into account the differences among colleges.
So it does study the relation for every college and then make the.
No, it's not this way, and I cannot explain with two words how exactly two-level models or three-level adjust the errors, but I think we need to be, at this point at least, willing to accept that if you take into account multi-level modeling, in this particular context, the only effect is that it will adjust the standard errors of those estimates that I am providing here. Because there are differences between the universities, it is well known. Differences not only on GPA, but differences on all variables that are involved here. All those differences are taken into account.
I'll make it very simple. Dr. Salam maybe he is shooting for a level of analysis that incorporates university.
Level of analysis that incorporate university.
Yeah, and the model.
Yeah.
Right.
That's what he's saying.
Two-level model would takes care of this.
The effect of the variation and then estimates the parameters. By standard error means the parameters are more accurate. The errors which will be introduced because of the differences, because of variation in the results of the universities are.
That's for pre.
That's
for pre-academic ability.
This is for all parameters in the model, not just pre-academic ability.
Does not apply. Of course, you have this data and the distribution of the students on all schools.
I don't, and I don't need it for this model.
You feed it in the model.
I don't need it for this model. The distribution of the schools, I don't.
Not schools, I mean colleges, universities.
Yeah.
You need the ID variable, which
Yeah,
For
state.
colleges, yes, there it is. There.
So it's been taken into account.
But it's, you know, sometimes, you know, I mean, some of the questions, you know, the data compiling depends on the research question. So this is out of the scope of this study.
Yeah, I mean, we have a study that focuses on specific research questions, and you take the information relevant and necessary to answer these questions. There might be all other types of information, distributions and comparison of means, which I don't need here.
No, it's not a matter of the research question, no. It's different. What Dr. Absalam is saying is that, let me talk about the correlation. Different from this. If you make correlation between between GAT and GPA, just GAT and GPA at college. Okay?
Okay.
If you sum up all students together without knowing who belongs to KFUBM and KSU, or you would get different results. From if you take in account those who is belonging to such university and another university and so on. So if you differentiate.
So basically, what you're saying is to do this study separated by clusters, separated by universities.
I don't know.
You mentioned that you tried it and the differences were not many. That's what you passed a remark in the beginning. So
I'm getting confused here, really. That's.
No, because you are not listening to me.
Yeah.
You are not understanding my thought.
Dr. Professor means without pooling. Just one pool versus a two level. You have one pool without any hierarchical structure.
Okay.
Level 1 analysis, purely level 1 analysis.
Yeah.
Compared with the level 2 which you've done now.
No, I did that, and the results are, the trends are the same. I said this at the beginning, right?
Yeah, that's what, they were not very different, but still, for the sake of accuracy, he went for a two-level model.
Yeah.
Then comes Dr. Ashraf's question for the regions.
So the answer is yes, you already taken this in account.
Yeah.
Don't say this is out of the scope. No, it's already taken.
Yeah. No. Listen, here the question is about.
Important because it's very important. We know that even at the teacher level, or professor level, some of them are generous. They give grades more than the other. My colleague maybe is very conservative and giving scores. And me, I am very generous.
Okay.
So there is differences. At the global level, if you look at, for example, this is from my previous studies, like King Abdulaziz University is very generous in grades.
Mm-hmm.
This is a fact. We should know this. And King Saud University was the worst. I mean, very conservative in giving.
Because of that guy, you know.
You know? This is a fact. I found it in my research. So, this is, of course, has an effect on the correlation, and if you don't consider the from where the student is coming. Okay.
There are two issues here. One is the differences that you mentioned that exist among universities, right? On all variables, GPA or whatever. When you run multi-level analysis, those differences contribute to more accurate estimation of the relationships that you're interested in. If, in addition to this, you want to compare some specific numbers across universities, that is simply a different study. We can conduct such study, nothing wrong with this.
No, we are not interested in that. Of course, multi-level, as you say,
Yeah.
takes this account.
Multi-level takes into account the differences among colleges in all variables, not just GPA.
Likewise, you can also use three-level structure where you take into account differences across regions. But at the moment, software like that doesn't allow you to use three-level structure. So some other software has. There are a few software you can use, but not have class. That is an issue with accuracy can be refined. And your another thing you just mentioned that high school grades they are very lenient, very strict. And that also compounds the problem of range restriction, which you and Dr.
because high school has been considered as uniform. Nobody is asking you from which high school you are coming. So
Yeah.
they take it as granted as a common.
Yeah.
But the GPA, of course, still now is questionable. You know, it's
Yeah, I agree.
From which university you graduated? They will ask.
Yeah.
Okay, Dr. Khaled is waiting for his chance to ask.
I get confused as you did it.
Go ahead. I'm already confused. ما في مشكلة.
Another question is similar to this one, but I think maybe you have answered it from your discussion. What I'm saying is that all universities follow the same numbers, almost. I mean, for the numbers we've got here, the correlation between.
No, they're not the same. There are differences among the
Yeah, I
universities.
know that is there any outliers? They say, well, this university is completely out of the.
By the way, to be honest, I just follow everything by the book. The first thing that I did, I ran ANOVA, analysis of variance among universities, to see the differences, right? And there are differences among universities, indeed. And I say, okay, I have to take into account those differences. That's why I'm using two-level model. However, if I want to focus on, which universities I like more, and then I can run just ANOVA on those results and provide all this information as a complementary research question. That's a different research question, which here in this study I'm not really focused on, but this could be done.
The other thing, before I just understand.
But-
I think
But which university is higher or lower has nothing to do with my questions. That's the whole thing.
No, I'm saying is that what's the effect of the GPA onto for the art and science? I think that most universities follows the same numbers. Maybe you find like one or two universities, they are like what they call it in the statistics outliers. They are far strange behavior. But I mean, this is a good research, and I think it should be done frequently, like every 2 or 3 years. And I wish from the NCA here to present it to the deans of admissions in their meetings and
Different perspectives, yeah, different perspectives on this study.
If I am
Yeah.
dean of an admission at a university, I would like to know about these kind of things.
Listen, I agree that there might be many important other questions that we can ask and address them in a different study, but that's just a different thing.
Yeah, we have to prepare like presentation, which is
Yes.
just, designed for those users who are the admission.
Good. That's a different.
Because they always ask us about feedback.
Yeah.
So
That's
they
it.
have their own feedback.
I understand.
But it's not.
Well, that's.
It's not.
Yes.
Not evidence-based. Not
Not
evidence-based.
quantified. But these are, of course, will be reinforcing their procedures.
Okay, go ahead.
Excuse me? I
What you are searching for now?
I'm looking just to run the analysis that you're asking me. That's what I'm looking for. I can answer your question right on the spot.
We don't have time.
No. خمسة دقائق. Until we process the next question. Go ahead.
Okay, I just want to put in consideration that people in science major, there is a high probability they have chosen to be in science major. However, people or students in arts science, there is a high probability they are in science they have not chosen to be.
Yeah.
This is one thing. The other thing is the number of observation of dropout or transfer. There is a high probability if you are in the major that we have not chosen to be. I'm afraid that the number of observation of transfer or withdrawal are more in art science than in.
I agree. We have to have information about this. survey, go. Why did you transfer? Why did you withdraw? I don't have this information here.
So I just
But it's
want-
important.
yeah,
It's important.
To account for, there is a high number of observation in art science, for example, rather than in major science, and science major.
Okay.
Okay,
I think it's time to close, I think. Mr. Dimitri, do you have any comments?
I had comments. I mean, just, really provide you one very small illustration of this analysis that you're doing. Okay,
Because I think
here we go. I will just run the analysis that you requested. And there we go. There's a group of colleges with different performances on College Gpa. And this is how they group. Those two are together, these two are together. So let's say you can even group them into groups of homogeneous performance, and this is the breakdown of colleges by universities. GPA, college GPA by universities. So all kind of analysis could be done, but they are out of the scope of this book, of this study. And I also appreciate your attention and your comments. Okay.